Hey there, and welcome to the Unit 10 Topic 11 video, Finding Surface Area of Conjoined Solids. All right, so let's get started. Okay, so we want to find the surface area of this figure. Well, the first thing is we have to notice that we have two figures. So we have this half a sphere, and then we also have a cylinder. Okay, so we're finding the surface area of this whole thing. It has like an R2D2 quality. Okay, so the first thing is we want to find the surface area of this half a sphere. So surface area of the sphere is going to be 4. So if we go to our formula sheet, surface area of a sphere is 4 pi r squared. But we only want half of it, right? It's not a full sphere. It's just like the top, like the hemisphere. So we want 1/2 4 pi r. So we have right here, diameter is 22. Okay, that's going all the way across. So remember, radius is half a diameter. So 11 squared. All right, so let's math that. All right, we get 242 pi, and I'm going to go ahead and leave that pi there. So we should try to get in a habit of not rounding very many times throughout a problem. This little slate I'm writing on is terrible. That says 242 pi. I can do better. I think I can do better. 242 pi. All right, the next thing is we have the cylinder. All right, so we want the bottom of the cylinder, but not the top. So we have surface area, which is the sides, the top, and the bottom. We have lateral area, which is just the sides, not the top or the bottom. But we kind of want like a hybrid right now. We need the bottom, but not the top, because the top has this half a sphere on it. So there's not going to be any top right here on top of the cylinder. So if I'm looking at this, I've got my cylinder, and I have to decide, do I want to do lateral area and add a bottom to it, or do I want to do surface area and subtract a top from it? So it really doesn't matter. We just have to know what we're talking about. So I'm going to use surface area. So if I look at the cylinder here, I got surface area equals 2 pi r squared plus 2 pi rh. Well, it's this part right here that's the area. That's the top and the bottom. Because remember, the area of a circle is pi r squared. So the fact that I have 2 pi r squareds, those are one for the top and one for the bottom. 2 pi r squares. Well, again, I want the bottom, okay? I want the bottom, but I don't want the top. So I just want one of those pi r squareds. And then, oh, it's so bad. This doesn't even look like a plus sign. Okay, 1 pi r squared for the bottom plus 2 pi rh. So pi r, remember, is 11 plus 2 pi r, 11 again, h, so that's talking about the height of the cylinder, 31. All right, so let's math that. And that gives me 803 pi, or whatever decimal you already did. If you already have your pi, that's fine. But when I add the total, okay, for my total, I need to add the sphere area that I got, 242 pi, and the cylinder area that I got. So 242 plus 803 equals 1045 pi. And I'll go ahead and now multiply it by pi, and I get 3282.96. So let's say it's round to the nearest whole number. 328, and then it's 2.96, so 3283. And we're in inches and it's area. Okay, so both of those added together. All right, second problem. Find the total amount of wrapping paper. All right, I'm going to get rid of this out of my area. Find the total amount of wrapping paper. So I'm going to wrap this up. Merry Christmas to somebody, or Happy Hanukkah, or whatever you celebrate. Okay, so the first thing is I'm going to look at this pyramid. Okay, this is a rectangular pyramid, right? So I'm looking at this. Once again, I don't need its bottom. Okay, so I'm going to be putting wrapping paper all along here, but I wouldn't like flip that up and wrap the underside, right? That'd be weird. So I just need to find the lateral area. I don't want the bottom, so that's perfect. So the lateral area, all right, of this figure on top, lateral area. Now let me take an inventory. What do I need? 1/2 L and P. All right, so L, remember, is slant height. So I need to find that. So if I draw a line over to here, remember I'm making a right triangle. The slant height is going to be the hypotenuse of this triangle. So I'll just maybe go out here. I've got, this is 2. This piece right here is like half of this. So 2.5 divided by 2 is 1.25. And then I'm looking for this up here. So x squared, the hypotenuse, equals 2 squared plus 1.25 squared. 2 squared plus 1.25. 2 squared plus 1.25 squared. 5.5625, but I want to take the square root of that. Okay, so I've got x squared equals 5.56 blah blah blah, but then I have to square root it, right? So x equals 2.36. We'll say 2.4. All right, all that was from a slant height. So my slant height is 2.4. All right, so slant height 2.4, so I've got 1/2. Let me go back to red. 1/2 times my slant height. So that's a 1/2 and a 2.4. It's really hard to read. Times the perimeter. All right, so the perimeter is like this plus this plus this plus this. So that's 2.5 plus, it's the same as here. So 2.5 plus 3 plus 2.5 plus 3. Or 2 times 2 plus 2 times 3.5. However you want to think of it. So you should get 11 for your perimeter. So 11. All right, so 0.5 times 2.4 times 11 gives me 13.2 for this lateral area, okay? 13.2 is the lateral area of the pyramid. All right, now for the bottom part, the bottoms. All right, so I want wrapping paper for like here, here, around the back, and on the bottom, but not the top. So here I'm in one of those situations where I don't want lateral and I don't want surface. I want something in between. So there isn't a lateral area formula for a cube, so I'm going to use surface area. Now, if I look at my surface area formula, it has me do like 2 of each of the faces. Okay, so like this, let's think about what that really is. Okay, the first part is 2 length times width. So this is length and width right here. All right, so that's like the bottom and the top. All right, that's exactly what I don't want, is the top. So instead of having two of those, I just want one. Now hopefully that makes sense. So the length times width goes right here and right here. So the side that those form is this bottom part right here. And then you want the one parallel. So in my picture, it's the bottom and the top. I don't want the top. I just want the bottom. So I just want one length times width. And then everything else, so let's take another look. Then we've got length times height. So length times height. You see how that makes this front face and the back face. I do want that, right? I want the front and the back. So I do want two of those. And then, so sometimes you just got to get really into it and just figure out what it is you're looking for. I think that's the part that makes this stuff hard. Width and height. So that's this face and then the face parallel. So, and I want both of those. I want this and I want the face over here. So 2WH. All right, so let's just fill it in. Length, okay, length times width. That is 2.5 and 3. Okay, and I can just say, like, this is length, this is width, this is height, just to be clear. 2 length times height plus 2 width times height. We're running out of room. That's a 2.5. So do all that in your calculator, and you should come up with 35. So my total is going to be my 13.2 plus my 35. So what does that give me? 35 plus 13.2. 48.2 feet squared. Okay, so like when you're wrapping presents, you don't need to just like buy a bunch of rolls. You can actually measure out all of your boxes before you go and then figure out how many square feet of paper you need, and you'll never overbuy again or underbuy. How exciting is that? So when will I ever use this? When you're wrapping presents and you want to save money.